So what I'm going to do, I'm going to look at all the even ones, 8 through 16, because each one of them kind of shows us a little bit difference of this LU factorization, and this is on page 132. And do 8. And so what we want to find is L and U for the factorization of this matrix 6, 4, 9, and 5. So just a little bit of review. If you go back on page 128, it says the algorithm for the LU factorization. It says reduce A to an echelon form of U by a sequence of row replacement operations, and then place entries in L such that the same sequence of row operations reduces L to I. So you want to have, for L, you want to have a diagonal of 1s. And so what I'm going to do is I'm going to go down here and build. I'm going to bring a 6 and a 4 down. That's this thing right here. And then what I'm building is L down here. And what I have to do is I have to get a 1. So I have to divide that 6 by 6, and then 6 into 4, and I get 2/3. Now, what I have to do with this matrix is I have to do row operations so that I get the 4 to be 0. So what I do is 6, 9, and then I got to do 2/3 of 6, a negative 2/3, right? That would get 4, 0. So I'm taking a negative 2/3 of 6 to get a 0 here, and then a negative 2/3 of 9 gets me a 6 here. No, 3. Okay. A negative 2/3 of 9 is going to be a negative 6, right? And then a negative 6 and 5 gets me a negative 1. Okay. And then I take this 1, put that minus 1 down there, and then I have to have a diagonal of 1, so I have to divide that by minus 1, so I get a 1. Put a 0 up here, and this is L. And then my U is this right here. Because what I have is I have my pivot points there. That's what I have to have. So LU. And then what should happen is LU should equal the A, and the A is at 6493. Then you can verify that. So if I do 10, and I have 10 as that matrix, minus 5, 10, 15, and then 3, 4, 9 minus 9, and 2. And then what I do is I take this right here, bring it down into minus 5, 10, and 15. And then to build my L, I gotta have 1 up here. And that would require me dividing that column by minus 5. So it's 1 minus 2 minus 3. So that's my first column of my L. And I do my row operations to get zeros, 10 into 0 and 15 into 0. So I got minus 5, 3, and 4. Then I have to multiply that row by 2 to get a 0 here. So this is minus 2. 2 times 3 is 6. Minus 8 is 2. 2 times 4 is 8. Minus 9 is a minus 1. Then I have to go 3 times 5 to get the 15 to 0, so it's 0. 3 times 3 is 9. 1 is 10. 3 times 4 is 12. 14. Now what I do is I take this right here, put that down here. And then to get a 1 here, I have to divide this one by minus 2. So then this is a minus 5. So I get my second column of my L. Minus 5, 3, 4, 0, minus 2, and minus 1. Then I have to multiply to get a 0 in that bottom of that second column. I have to multiply second row by 5, and that's 9. Now I take this value, that goes there, and I divide that by 9, so I have 0, 0, 1. And I have my diagonals 1, which it says I need for my L. And then this is equal to the U. So my 12. It's 2, 1, minus 6, minus 4, 5, minus 2, 2, 4, and 4. So I take this, put it down here, build my L. I need to have a 1 up here because I got to have diagonals of 1. So I'm going to divide each one of those by 2. Then I have to get 0 in that second row. So I'm going to have to take 1/2 of 2, negative. That's going to make this 0. Negative 1/2 of 4 is a positive 2. 5 and 2 is 7. Negative 1/2 of 2 is minus 1, makes this a 3. And I'm going to have to take 3 times the first row, so that makes this 0. 3 times a minus 4 is minus 12, minus 2 is minus 14. Now I take a negative 2 times that is I've taken 2 times that. 2 times 2 is 4, so that's 8. Okay. Oh yeah, that was 3. 2 times 3 is 6. Yeah. Somehow I lost my train of thought here. Thanks. Now then, this, and it goes down here. It's a 7 minus 14. So then I have a 0, and I've got to divide that by 7. So it's 1 and minus 2. Then I got to eliminate the minus 14. So I got 2 minus 4, 2, 0, 7, and 3. And I take 2 times the second row, so that's 0, 0. 2 times 3 is 6, and that's 16. So this is equal to u, and the 16 comes down here.
I think there's some stuff here. The original problem, second row, third column, fourth. So this is right.
So this was supposed to be a negative?
Yep.
Oh, wonderful. So, how far back are we going to have to go?
I think you want to change the one thing here. Thankfully, it's in the last column.
When I did this row right here,
Yeah.
I took 2 times the, I took 1/2, right?
Let's see, negative 1/2, 0.5, so that's a negative 3 instead of 3 here.
Okay,
Second thing is plus.
negative 3. So this was a negative. And then that'll change this, right?
Yep.
Okay. 3. So 2 times negative 3 is a negative 6, and this makes it 4. So then this becomes 4. And then we divide by 4 to make it, because we have to have a column of 1s, or diagonal ones. And this is my L. That's my U. And once again, to verify LU has to equal A. So let's look at 14. Crowder over here. Probably going to take it. So this is 1, 4, minus 1, and 5. 3, 7, 9. Minus 1. 6, minus 1 and 7. Okay, so do I have that one right? So this comes down. So it's 1, 3, minus 2, minus 1. Now to get our L, this comes right straight down because we have the diagonals.
Fourth column, it's a -4, not -1.
This is a -4 here. On 14.
Okay. Fourth column, third row.
Fourth column. Okay, this one over here. Okay. It's not bothered us yet. Okay. So now what we have to do, we got to get zeros down that first column. So it's 1, 4, minus 1, 5. So I'm going to multiply the first row by minus 3. So I get 0, minus 12 and 7, minus 5. That's a plus 3, minus 2 is 1, minus 15, 9 is 6. Is that right? Yeah. And the first row by 2 is 0, 8 is 5, negative 1, that's 6. Now let's add that down. 0, 10, minus 2, I think that was a 7, wasn't it? 12. Okay. So now this one comes down. Minus 5, 5 and 10. Now to get our diagonals of 1s, we have to divide that one by minus 5. 1, minus 1, minus 2. So it's 1, 4, minus 1, 5. 0, minus 5, 1 and minus 6. Now we have just multiply it by 1. 0, 0, 0, 0. Now multiply it by 2. 0, 0, and 0. Now, what we have to have, this is going to be our U. So that's U. Now what we have to have is a diagonal of 1, so we got to put 0, 0, 1, 0, 0, 0, 0, 1. And that's going to be our L. Because if you look back on the LU factorization, it has to have, it says we have to have a diagonal of 1s for the L. Okay. So that's a little bit different than what the previous ones are. And the 16 is going to be a little bit different too. So it's 16. It's 2 minus 6. 6. Minus 4, 5, 7, 3, 5 minus 1 minus 6, 4 minus 8, 8 minus 3, and 9. So once again, we take this, 2, 4, 3, 6, and 8. So we have to have a 1, so this could be minus 2, 3 halves, because we're dividing by 2, minus 3, and 4. So we multiply that by 2, 0, 12 minus 7, 12 is a 5. Now we have to take the first row by 3 halves minus, makes this 0, 3 halves, so that's going to be minus 9 is what 3 halves of minus 6 is, plus 5 is minus 4. And that's 9 minus 1. See, that was negative. I was having to take it times a negative 3 halves. So when I take a negative 3 halves times a minus 6, I get positive 9 and 5 is 14. This is 14. Then a negative 3 halves times 6 is a negative 9, minus 1 is a negative 10. Did I do that right? Now 6, I have to take it times 3. So that's 0. 3 times 6 is a negative 18. Negative 14. Positive 18. Positive 10. Take it by minus 4. Something's wrong. It's a minus, isn't it? Yeah. Because I'm taking it times a minus 24. So that's a minus 15. And that was 10. Okay. Well, this right here comes down here. It's minus 7, 14, minus 14, 21. So we have diagonals of 1, so we're going to have a 1, so we're going to divide it by minus 7. Minus 2, 2, and a minus 3. Okay. Minus 6, 6. Now I have to multiply by 2 to get rid of the 14. 0, 0, and that's 0. Now I multiply it by a negative 3. 0, 0, and that's 0. Because this was 10. That's 10. positive. Then I multiply it by 3. Okay. So this is U. And then I have to have my diagonals of 1, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1. And that's L. So notice if we do LU equals A, this matrix is 5 rows by 3. And this is a 5 by 5. And L would have to be a 5 by 5. You couldn't have cut it off at 2, or you couldn't have multiplied LU, because you have to have the same number of columns as you have rows in the U to do the multiplication. So there's the L and there's the U. And then your result is going to be a 5 by 3, and that's what A is. So it has to be that way with those diagonals and ones. Now the next one I'm going to do is 18. This says find A inverse as in exercise 17. And in 17, what they did was is they got if A is equal to LU, then A inverse has to equal L inverse U inverse. And that's what they've done up there. So what we have to do in exercise 3, they're giving us the L and the U.
Didn't you learn for inverting matrices that we inverse multiplication back to this is a special case.
But if L is invertible, if it's invertible, you can go back to that invertible theorem, and it says that you either take C times A or A times D if they're invertible. I mean, that's so an invertible matrix, you can either do L inverse or L inverse L by that theorem 8. So it says, if you look on 114 and you look at J and K, if A is invertible, then there's a matrix C such that CA equals I, or D such that AD equals I. So you can multiply the invert times both sides as long as you're a square matrix.
That was excluded. That's kind of hinting that the commutativity of inverses. That's all I was trying to.
Yeah, if you don't have a square matrix, this A in exercise 3 is a square matrix. So if it's a square matrix, then that theorem 8 applies.
Mm-hmm.
And in theorem 8 is if it's invertible, then you see theorem 8 says, it's saying A is a square matrix n by n, then the following statements are equivalent. And if A is invertible, that's theorem 8a, then both J and K are true. So then there's an inverse. So L is invertible, U is invertible. So there is a C such that C times A equals I. And there's a D such that, A times D equals I. So if there's an inverse, L inverse, then it's L inverse L equals I, or L inverse equals I. As long as it's square. But if it's not square, then what you got to do is you got to transpose the inverses. Yeah. Because otherwise you can't do the multiplication if it's. Yeah. Yeah. Well, I'm glad I'm able to answer with my limited knowledge. Okay. So what we have to do is we have to find the L inverse. And what I'm going to do is I'm going to do the L is the 1, 0, 0, minus 3, 1, 0, 4, minus 1, 1. And then I'm going to do 1, 0, 0, 0, 1, 0, 0, 0, 1. And this is the idea if you got U times I, UI, U augmented with I, then if you interchange it so that you have I on this side, you will have U inverse. So if you do row operations so that you get I on the left, then you'll have U inverse on the right. That was, I don't know, back a ways that said how to do inverses. If you got a square matrix, a 2 by 2 square, then there's a theorem that says you can do 1 over the determinant times changing the A, A, B, C, D, changing the A, putting it down in D and the D up in the A, and then interchanging the other ones with negatives. But that's only with 2 by 2. But if you're going to do anything bigger than a 2 by 2, this is the method that you want to use. So what I'm going to do is I'm going to take this thing and by row operations turn it into I on the left. So I'd have to take a 3 times the first row. So I got 0, and then this is 1, 0, 0. No, got to take 3 times. Back up. Taking 3 times 1, so this becomes 3, 1, 0. Now I got to take minus 4 times the first row. So that's 0. It's minus 1, 1, minus 4 times the first row, minus 4, 0, 1. Have I done that right? I think so. Now what I want to do, across the first row, And then I got 0, 1, 0, 3, 1, 0. Now, to get rid of the 0 in that third row, second column, I have to take a -1 times the second row. 0. And this is still 1. -1 times 3 is -3. Okay, -4 is -7. -1, -1, and 1. Now, did I do it right? I should have. So that's right, isn't it? Okay. So now what I have is I have U inverse is equal to 1, 0, 0, 3, 1, 0, -7, -1, and 1. L inverse. That's U. Which is it? That was L, wasn't it? It's an L. This was L. I mistook this. This is LU. L inverse. So this is L inverse. That's what I was getting. Because that first matrix is L. Now I have to do the same thing with my U. So I have to do 2, 1, 2, 0, -3, 4, and 0, 0, 1. Then I go 1, 0, 0, 0, 1, 0, 0, 0, 1. And this is U, and this is I, and I got to convert it to I, U inverse. So I guess I'm just going to come across and wait till the end. I don't think I want 1/2 there. 1. No. I would. All right. I want to go from the bottom up because I got a diagonal with zeros. I got an upper echelon diagonal, so I have to start down here and then go up, right? Get that column clean of zeros. What I want to write is my 0, 0, 1, 0, 0, 1. And now I want to get rid of that 4, so I have to multiply the bottom row by -4. So it's going to be 0, -3, 0. That's going to be 0, 1. And multiply the bottom row by -4, so this is a -4. Now I want to multiply the bottom row by -2, so I go 2, 1, 0, 1, Now I'm multiplying that row by minus 2, right? Minus 2, 0. Now what I want to do is I want to get rid of this 1 right here. At this point, it would be, no, I don't want to divide by minus 3. I want to take 1/3 of that second row. So the top is 2. 1/3 of that equals that's 0. That's 0. That's 1. Now 1/3, and I'm adding the minus 2. So I'm going to minus 2 plus 1/3. I gotta go 3 over 3, right? So that's a minus 6 plus 1/3, so that's a minus 5/3. Minus 5/3, and where the heck am I? Minus 5/3. I'm multiplying a minus 1/3, right? I'm multiplying 1/3. So it's a minus 4/3. Okay, now it's 0, minus 3, 0, 0, 1, minus 4, 0, 0, 1. Now I got to divide the top row by 2 because I got to get a diagonals in ones. 1, 0, 0, 1/2 minus 5, 6 minus 4, 6. I'm going to divide this by minus 3. 1, 0, 0 minus 1/3 plus 4/3. And then this one is this. So this is U inverse. One half minus 5, 6 minus 4, 6, 0, negative 1/3, 4/3. Okay. So now what are they asking us? Well, for some reason, I didn't come out with what I did when I worked it. Do you see any errors that I did? Did you come up with the same answer?
Everything's the same except for last two entries on the first row.
Yeah, these two right here.
I got a 1/6.
Negative 1/6 and negative 1/3.
Positive 1/6.
think it's supposed to be negative 1/6 and a negative 1/3. I don't know where I made the error. What approach did you take?
I just looked at it as by the top row by the field, used a whole bunch of fractions.
So, same process, just different.
Same process, just kind of grit my teeth and take care of the fractions.
Okay. Well, let's see. Anyway, I'm not gonna go searching for it, but you should be able to get A inverse from multiplying those two times each other. It's tedious for me. All right, so quiz.